In machine learning, many model candidates are generated during training. To address the problem of model selection, we introduce ML-ModelExplorer, which is a model-agnostic approach to evaluate, compare, and select multi-class classifiers. To show the approach, we trained convolutional neural networks on the MNIST handwritten digits dataset. The kernel size of the convolutional layer was increased from 2 to 11, which results in 10 different models. On the right-hand side, we can load own datasets and filter the models and classes. We will show the tool with the preloaded results from the MNIST dataset. The model overview pane is subdivided into, on the top, an overview with metrics and ranking of the models. In the middle subpane, the per class errors. And on the bottom, a detailed insight into the class confusions of all classifiers. The model rank view can serve as a starting point. The models are ranked according to their classification imbalance and their average recall. In addition, they are grouped into strong, medium, and weak models. For example, for that dataset, we can see that Model 8 and Model 2 are promising models. In this plot, the models' accuracies are contrasted with each other, and in addition, in reference to random classification, to simple classification of the majority class, and to the overall model average. The dispersion of the recalls of all classes are contrasted with box plots. Box plots positioned at the top show stronger models, and the height corresponds to a model's variability over the classes. For the neural networks on the MNIST data, we can see the strong effects of the kernel size, with a kernel size of 7, 8, and 9 yielding the best results. The similarity between models are visible on the right, where the accuracy and the standard deviation of the recalls are shown in a 2D scatter plot. For the MNIST data, this plot reveals a group of strong models with high accuracies and low variability over the classes. These models are model number 8, model number 2, model number 7, and model number 6. The visualization on the bottom allows to navigate through the hierarchy of the errors per model and per class and the class confusions. The errors are ordered clockwise, so we can see the errors in ascending order. For example, we can analyze model 8, which from our previous analysis appears to be the best classifier. We can now identify the weak spots of this classifier. We can see it has the most class confusions on digit 9, which in turn is most often misclassified with digit number 7 and digit number 4. So there might be optimization potential here. In the model details pane, we can further investigate the class confusions of one classifier, for example in a chord diagram or in the visualized confusion matrix. In the tree map, the errors are ranked and we can see how they are composed of the individual class confusions. It's thereby easy to identify weak spots of promising models. For example, model number 8, which again is our most promising model, seems to have a problem with the detection of digit 9, which is most often misclassified as 7, followed by 4 and 1. And finally, in the model comparison pane, we can select two classifiers and compare them. The differences of the two confusion matrices are shown on the left. So we can see where exactly one classifier performs better than the other. Green cells show better performance of the comparing model, which is the second model selected. On the right-hand side, we have a radar chart contrasting the two selected classifiers. It gives us a comparison at one glance. So for example, here we selected the two promising models, Model 2 and Model 8. And we can see that Model 8 in general has a lower error on all the classes except on the detection of digit 8, class 8, and a slightly worse error on digit 2. The dashed line here shows the average over all models, so what we can see is that both models are well better than the average. So for example, what we could do is to find diverse models that we can combine to build an ensemble that will end up being a better classifier. Thanks for watching the video. You can find more details in a paper, and you're invited to test ML-ModelExplorer.